So for those of you who came early, thanks for filling out this survey. Surprisingly, 15 people did, which was, I was expecting like 2. So that's lovely. But yeah, we're going to talk about validating big data and ML pipelines with Apache Spark, stopping failures before they get to production. If anyone wants the slides, they will be at this wonderful bit.ly link. They may already be there. They may not. I have a Python script that is uploading them as of 1 minute ago. So we'll see. So yeah, I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist, which is very convenient for mornings. I'm a developer advocate at Google. I focus on open source big data stuff. I'm on the Spark PMC, and that means I'm also a committer. That means it's really difficult to get me out of the Spark community, so y'all are stuck with me for the most part. But it also means that I get to do fun things like review code. And if that tricked any of you into thinking reviewing code is fun, please come and join me. I'm a co-author of 2 books on Spark, well, actually 3, whatever. Learning Spark and High Performance Spark are the somewhat more up-to-date ones. You can follow me on Twitter. And if you actually do think code reviews are cool, or if you don't think they're boring yet, you can join me doing live-streamed code reviews for Apache Spark. And I assure you this is more interesting than it sounds. And it's a great way to get familiar with the Spark code base and also be able to help influence the Spark code base and have your work recognized by the committers and PMC members as if you start to review more code. And you should come and help us review. We have over 400 pull requests that are open and many less than 400 people to review them. I've got a bunch of previous talks on Spark as well. If you have feedback that you want to give to me directly, I know the conference is also collecting its own feedback. I have a feedback link where I collect talk feedback. And if you're interested in random machine learning stuff, I'm working on yet another book. It only has 1 chapter on Spark as opposed to being mostly about Spark. It's called Introduction to ML with Kubeflow. It should be finished sometime before the heat death of the universe. Not a guarantee. Okay, so that's all fun. In addition to who I am professionally, I'm trans, queer, Canadian in America on a combination H-1B work visa and employment authorization card, which can be revoked at any time for no reason, and part of the leather community. And this is important for a few different things. You're all here presumably because you're building machine learning pipelines. And I think it's really important for us to try and have diverse communities building our machine learning pipelines so that we don't just solve yesterday's problems worse with data. And one of the things that we have to do is we actually have to talk about where we are all from. And so if you're working on an open source project that's doing some cool machine learning stuff, and you look around and you realize it's your 5 friends that you went to school with, try and grow that project to include some of the people that maybe you didn't go to school with, and that your life will be better. Okay, I'm going to talk about what validation is. Presumably you have somewhat of an idea because you came to a talk about it, and why you should do it, how to make simple validation rules, specific considerations for machine learning, and cat pictures. Also pictures of a scooter club. That is definitely not a gang. I want to be 100% clear, the sparkling pink pandas are not a gang. We are a social club. Okay, so I'm hoping you're nice people. You've laughed at most of my bad jokes, so that's a good start. Is anyone totally new to the Spark community? Yay, welcome new friends. I'm so happy. It's good when there are new people here. There's only 3, but maybe there are other new people who are just afraid of admitting that they're new. I'm so glad that there are new people here who are going to do excellent software engineering things and build really cool models, and we're gonna have so much fun. Probably you're here because you want to make better software. Possibly you're just here because you don't want to get fired. That's pretty okay too. I gotta say though, in my personal experience, it is really hard to get fired in the Bay Area for screwing up a data pipeline. And I've gotten pretty close, and we'll talk about some of those. Yeah, okay. So possibly this is you. You're using Spark, so everything is awesome. Okay, movie reference for 3 people. Okay, alternatively, how many people here have their motorcycle license? Okay. Keep your hands up if after doing the California written test, you felt confident that you were going to be able to ride your motorcycle well. Okay. That was 0 people. And unfortunately, I think our software tests are not entirely dissimilar to the bad parts of the California DMV. They do indeed test for something, and if they fail, I have some very serious questions. This is my lovely friend getting ready to ride a scooter. And actually in San Francisco, you can ride these things without even passing the California DMV test. You can do it by watching a YouTube video and answering 4 multiple choice questions correctly. And if you get them wrong, it just sends you back to the start. And so like, you don't even have to be a very smart machine learning algorithm to get your license in California. And this is terrifying because I like my friends, we ride scooters together, and I don't want them to be dead. And in a similar way, I like data pipelines, and I would much rather that we not kill everyone with bad recommendations. Now, if we're just recommending cat pictures to people, okay, but people are using this stuff to do real things that like impact the world, and it's terrifying. Just like people are riding scooters on real roads after watching a YouTube video and answering 5 multiple choice questions. It's terrifying. Okay, so why don't we validate our stuff? Even in the like 15 people or so that answered in the survey had come to a talk about doing validation, there was at least one person who selected the box, what do you do to test or validate Spark, and centered none. And that's fine. If you're that person, that's okay. I'm really glad that you've shared that with us. But it's not okay to keep doing that long term. We have to fix that. So we think maybe we've got good test coverage. So what could go wrong? Possibly at all, right? And also, it's really hard to instrument distributed data pipelines. It's a lot of work, and like, I could just go home. It's pretty okay. Okay, but this is a talk about why you should do this, and so it's because your tests aren't perfect. You are the California DMV. You are going to fail, and at the very least, you're going to want to know when you failed, right? You don't want to be the person who's like on the captain of the sinking ship and trying to serve caviar to people, whatever, food items. I didn't eat a lot. There's gonna be a lot of food-related analogies. And so at some point, we're gonna fail, and the real world is just gonna be more creative than our testing is ever going to be. So many things can become null in the real world that I just didn't think were gonna be null ever. Or the value empty string instead of null. That's a great one, I love that. Okay, so why should we do this? 37.6% of people have the results of their Spark jobs automatically deployed to production without a human in the loop to sort of stop it from catching on fire. So if you're gonna do that, you probably want something to keep bad things from happening so you don't get woken up at 2 o'clock in the morning. On that note, 16.9% of people said yes to has the output of your Spark job ever caused a serious production outage? I take this to mean 16% of people had to update their resume before having a conversation with their boss. 30% of people felt pretty confident that no one else understood the Spark system and they weren't gonna get fired, but they still had an outage and an awkward conversation with the boss. And the remaining 50% of people don't use Spark in production. Okay, cool. Well, that joke worked. That's lovely. Okay, so what's gonna happen when we don't validate? So one of the things that we might do is we might go on a scooter ride, the new rider is gonna be in the back of our pack, and then they're just gonna sort of fall over on the side of the road. Are gonna keep riding home, and it'll be fine. It'll be fine. Or they're gonna fall, break their bones, but adrenaline's magical, so they'll just keep riding, because that's really good, right? Okay, or with computers, we can do all kinds of lovely things. So there's that time that I worked at a small retailer who sold books and other items. And I was like working on this feature, it was pretty cool. We came up with this new idea. It like totally worked on my machine. That's the good start of every deployment story, right? Put it put it into production, and yeah, later on that day, I had to be like, oh, hey, boss, we should have a conversation. I think I just lost us $3 million. I'm not entirely sure. It might only be 2. And like, you know, I should have known better. But in my defense, I was young and writing Perl, so we've all done things that maybe don't reflect super powerfully on us. Another time didn't involve real money because San Francisco, I just decided to stop working for places that make money and instead work for startups. And so I made some changes to a search system, looked totally good. Or more accurately, like I made some changes to a search system. I pushed a new version of my data pipeline, and it was totally great. I did one test query. So I actually did manual validation. My manual validation was making sure I could find a coffee shop. The only problem was the only thing it populated was coffee shops. And my boss did not find that amusing either. I didn't have to find a new job because engineers are very expensive in Silicon Valley. Okay, and then the other one. So it turns out some words have multiple meanings. And if you work in a thing where you work with humans, and you work with humans ranging from very, very tiny humans as your customers, and probably not like small children working at the same company with me, but maybe, whatever, things have happened, to other people. And someone searches for rabbit on your search system. And you do this, of course, before you go to production the first time, and you realize that, yes, I do not want to have to explain to someone who is upset that we showed their small child restricted content, right? We should have a system in place to limit this and make sure that we only show certain kinds of rabbits to the right kinds of people, right? Queuing systems, notoriously bad to show to children. Rabbit MQ joke. Okay, well, anyways. So we had a lovely system, and that was totally fine. However, this really lovely other team decided to update their data pipeline. And that was very all fine and well. And we had a schema registry. It was really, really cool. So you couldn't change the schema without like actually talking to people. Really cool. So they didn't want to populate a field anymore. And if they changed the schema, well, they would have had to talk to people. So they just stopped populating the field. And they didn't have to talk to anyone to do that, but I did afterwards. I had 15 minutes to resolve that, and that was fun. And then there's a whole bunch of other examples which don't involve me. I haven't worked at the VA or Bank of America, but there are wonderful examples of the terrible things our data pipelines can do. Just, we're running the same one, but something's changed in the world around us, and our tests didn't catch it. So if we knew that we did something vastly different, maybe we can have a better life. Okay, hopefully I've convinced you that this talk is worth listening to. If not, it is an excellent time to take a nap. Okay, so we're gonna focus on actually doing validation. So once again, we're gonna return to scooters and something that is near and dear to my heart, which is Slurpees. And now, how many of you have had a Slurpee? That's pretty high. How many of you have had a Slurpee that tasted kind of funny? Okay, that's a good number of people, right? And so we can see that certainly, while Slurpees are delicious, occasionally the Slurpee machines will produce things that we don't necessarily want to consume. And ideally, we catch that problem before we're like 2/3 of the way through the Slurpee and going, I don't feel so good. So one of the rules could be that our Slurpee should have some color in it. This is pretty reasonable if we look at the problem space of Slurpees historically. We've got things like red cherry, blue something, and other things that make you think that they may have once seen a fruit. However, there is a new product, and I want to tell you it is bad, but it is still a Slurpee, and it's the Slurpee Ghost White Gummy flavor. And so our validation rule that the output of the Slurpee machine should have color in it will eventually fail, and we'll have to update it. But I want to be clear, I think it's okay for our validation rules to fail, right? There's not a new Slurpee flavor every week, and it's okay that the fact that there is a new Slurpee flavor and that this new Slurpee flavor is unlike any other Slurpee flavor I've seen before means that human interaction is required to go and talk to the cashier about whether I want to try this like Slurpee Ghost White gummy flavor. Like that's an okay rule to have. So how do we do this with software instead? So ideally, at one point, you had software that worked. At least it worked on your machine, right? And if you don't, then you need to go back to that whole like making software that works phase. Validation isn't going to be able to like help us too much just there. If you don't know if your software works, which is a totally normal state to be in, you can start with manual validation. Ideally, learn from my mistakes and use more than 2 test cases in your manual validation. But validate that your pipeline is behaving the way that it's working. The problem is, we don't want to do this every time we produce a new machine learning model. And so if I have to do this for every time my data is updated, my job has gone from getting to play with really cool code to looking at the outputs of a diff file every morning. And that is a degradation in the quality of my life. I just realized, actually, I do look at the outputs of a diff every morning. It's just, they're code diffs. I'm not sure if that's better or worse. Anyways, OK. So how many people work with JSON? Keep your hands up if all of your JSON records are valid. OK, normally there's 1 person, and they've got like 6 megs of data. But OK, so with our JSON records, we're going to parse them, and we're going to throw a lot of them away because they're garbage, right? But maybe if I throw 95% of them away, that might be bad for my machine learning model that I'm going to produce. It's going to have like 5% of my records. So this is OK, provided that I have a line on a new job. So maybe let's say, for example, USCIS suspends H-1B premium processing. It'll take 3 months to transfer jobs. I can't count on changing employers immediately anymore. It's time to write reliable code. So what we'll do is we'll write this validation function, and it'll validate my input. Like, it'll check to make sure that my JSON is valid, and it'll let me know when it isn't. And I can say, if I have less valid data than good data, my life is sad, and I should not put this into production. This is kind of not like super fun to write, though, all the time, right? Right, and then we attach it to a Motorola pager because we hate ourselves. OK, and so this is less than fun. And from a Spark point of view, like the code isn't very pretty either. And so that's kind of sad. So we could use counters. And the nice thing is, if we use counters, we can actually collect them in nice ways. And then instead of just writing a rule that looks at it state once, we can look at how our rules are changing over time. How the values are changing over time and write rules with them. If anyone's in the Apache Beam world, they also have their own counters, so does Flink. Everyone has different built-in counters because industry standards are for suckers. In Spark, though, we can look at the web UI and see what counters we've got, and that's pretty nice. Although there's some extra hidden ones that don't show up because I don't know why. I'm pretty sure there was a good reason for that. And we can add counters for things that we care about, and we can still pretend that we have nice code. And so that's nice. And yeah, right, so counters are friends, but they're the kind of friends who steal your lunch money, which is to say, like, they'll like work the first few times, and they'll work every time your parents are around, right? Like, when you're running it on your local computer, counters will just totally work. They'll be like, yeah, no, everything's good. But when you put it into a cluster, they'll be like, you know what? I don't feel like doing any work today. Yeah, anyways, I had an interesting childhood. So what does that look like? So this is our counter. We have a happy counter and a sad counter. And then later on, we do some business validation. And so Spark counters aren't great for data properties. And that's why I don't just count the sad things. I count the happy things and the sad things, because the counters will be wrong some of the time, but normally, relative to each other, they'll be accurate, which is a kind of weaselly thing to say. I had a plan to fix this. That pull request has been open since 2016. It's not going to happen, but it's OK, right? So what are we gonna add counters for, and what kind of validation rules are we going to make using those counters? So according to a really depressing survey, and I want to be clear, the survey that I ran, it wasn't just like the 15 people that showed up here. It's like obviously like the 15 people that showed up here and answered the questions, but also the people who answered these questions from me tweeting about it at least 3 times, so we know it's a representative sample. And it turns out most people just check the execution time. And they're like, my Spark job took 3 hours today, and it took 3.5 hours tomorrow. Yesterday, whatever. These are close enough, ship it. And that's what people do. And that's really sad. But if you're not doing anything, that's a great place to start. You can check how long your Spark job is taking, and if it goes down a whole lot, that means something has changed. It's possible you're an amazing programmer. It's also possible the thing that's changed is your data went away. One of the two. I'll let you make your own bets. Okay, I have like a proof of concept thing which has some built-in rules for doing things like this, and it also has rules for doing things with historical data, so we'll look at some of those. So input schema validation, we talked about this. Everyone is JSON data. Everyone's life is sad. That's okay. We want to know how much data is not matching our schema, and we should definitely check that. That being said, most people don't, but you should, please do. Okay, and we need to think about our domain. And once again, we return to the domain of writing scooters, which is clearly related to Apache Spark. And so the domain here is that we have a scooter ride, and that we turned on a bubble machine, and then the road got a little slick, and that didn't go so well, right? And so a good validation rule from understanding our domain, like we might not know that our bubble machine is gonna cause this problem. If I thought that through, totally legit, should have seen that coming. But a good validation rule for a scooter rider could be like, if there's something weird on the ground, maybe I'll slow down, right? And that'll decrease the number of like failures that you have, and you can manually inspect it. And failures in this case is the broken wrist that happened. Anyways, okay. Instead, though, we can have counters for the number of times our business logic is going to fail. And instead of dividing by 0, which is going to fail 100% of the time, a much more reasonable counter could be like the number of times that we fail to generate a recommendation for any of our users, right? We expect some users, we might not be able to come up with reasonable recommendations for them, but if that number spikes, I have some serious questions that I need to answer or avoid answering. The other thing is, like, we've been talking about things in terms of things that we can do in our code, but we could also look at the inputs as well, sort of separately or in parallel. We can look at the percentage of data that's changed. If, day over day, my input tables aren't changing all that much, and, tomorrow I have 95% of my records are different, that means someone made a schema change without telling me. And that's an excellent thing for me to investigate and not push a new model until I've taken the time to understand what's happened. It's kind of expensive to compute, but you can run it in parallel to your main training job, so you don't have to block on doing it. It's not so bad. Which leads to another thing. So we've been talking about doing counters, which are sort of in line with your job, but you can definitely do things that are in a separate job that will analyze the inputs to your job and make sure that things are potentially reasonable. And you can also analyze the outputs of your job. So how are we going to analyze the inputs and outputs? So we could manually write a bunch of joins and SQL expressions. Who wakes up in the morning excited to write SQL expressions? There's got to be someone here. Yay! Okay, so that's the solution for you. And that's great. For the rest of you, though, there's some open source libraries. One of them is from my glorious employer, who can do no wrong. Its performance reviews are delivered tomorrow, and so they are perfect in every way. Although, ask me after noon tomorrow, and it might be a different answer. So TensorFlow data validation is really cool, and it does schema inference, anomaly detection, and a whole bunch of really fun things. It doesn't work in Spark. It's pretty close to being able to work in Spark. It works on top of a library that kind of works in Spark. There's just a few minor things that need to be fixed. There is a pull request to make it work in Spark, but if you're like, I'm gonna go use this in production today, no. But 6 months from now, you can totally use this library. Who's excited? Yay! I'm excited there's some people with standards lower than mine. That's lovely. Alternatively, we can be like the person who really likes SQL, and we can look at TFDV and re-implement all of that by hand. I was really thinking there was going to be more people interested in that. Okay, but more realistically, what we can do is a lot of the things that TFDV does, they're not pre-implemented in Spark, but doing schema generation and schema comparisons, not that complicated to do in Spark. We can compute summary statistics and compare summary statistics by hand in Spark. It's not automated for us, like we have to manually do this, but it's eminently doable. It's not like you've got a big problem that you need to undertake. The last part that TFDV does that's really cool, which is anomaly detection, that one's a bit more go find your favorite vendor sort of answer, or go and listen to some of the other talks at this summit about ways to do anomaly detection. And you can try and apply anomaly detection on your inputs to see if things look really weird. Okay, cool. So that's data changing. But a lot of the things that I talked about that I'd personally fucked up, damn it, that I'd personally exceeded with in a negative fashion, was software changes. And often for the better, right? But how many people here have upgraded Spark and noticed that something has changed? Okay, the rest of you do not use multiple versions of Spark. I am confused, but that's okay. And so there's a really lovely PyData London talk that I linked to, specifically about how this impacts ML models. And it is terrifying. She tried different versions of scikit-learn, sklearn, whatever. She tried different versions of a machine learning library with the same configurations and the same data. And the CV errors are like this. If you can't see, that's up and down, and then, ooh. Oh, and then there's also some missing ones where it just failed to run for some reason. And so what it turns out is that software engineers have no idea what a minor release is when it comes to a machine learning platform, right? So upgrading from 2.4.0 to 2.4.1 might break everything. It might make everything better, but you can't just upgrade. You're going to need to check. Now, thankfully, we can actually, if we're upgrading our dependencies, and we know we're upgrading our dependencies, we can compare the outputs of the old and the new on the same data and see if it's actually getting better. However, sometimes, helpfully, the vendors or valued partners that you work with may help and offer you a new version in that they deleted the old version and replaced it with the new version. And in those situations, good luck. Okay, so let's focus on some more ML-specific things, right? We talked about cross-validation just a little bit. It's going to be more difficult to try and run sort of output validation, right? Linear regression model looks kind of similar to yesterday's linear regression model. Although if it comes out as null, yeah, we should definitely stop that job. Okay. So the classic thing of looking at an output size to determine whether or not your job went well, that's not going to work anymore. You can look at your cross-validation performance. You can save a fixed test set, which is really good if, for example, your input data just gets totally hosed. You can have wonderful cross-validation performance when all of your inputs are null. But your fixed test set will hopefully catch that. You can definitely should look at the number of iterations and the convergence rate. And thankfully, these things, for the most part, are tracked in counters. If you're doing this inside of Spark, if you're doing it with another library, you'll get to write your own counters. And you can also look at different hyperparameters and stuff. Okay, so in the old days, we deployed models by going and finding the data scientist who wrote that model, probably a year later, and asking them to update it. Normally takes about a year to find them again, because they're pretty good at hiding. Human goes through their model runbook, they do some big data, they deploy it to X%, look at some graphs, and they say, everything looks fine, that's great. In practice, though, Right, okay, yeah, human is cornered by stakeholders and forced to update models. Also known as Holden, it's performance review time. Why haven't you updated any of your models? Spend a few hours trying to remember where that guide that you definitely wrote is. Realize you don't have it, but you do have untitled_7.ipython notebook, and you're pretty sure that's the good one. _8 was a little fishy, but you remember 7. 7's your lucky number. So you go ahead and you run it, and you come back with a trained model. And then you just deploy it, and you go and you read your favorite place of infinite sadness, and then you press deploy. Notably, you don't check anything in between doing the 1% test and the production version. Alternatively, we can use computers. Ooh. Very exciting new thing. Super, super interested to see how this one goes out. This is really nice. A lot more people are putting their machine learning models inside of things like Airflow to automate scheduling of updating the models. This is really nice. The computer can automatically handle the deployment and do rollbacks for us. That being said, at the end of the day, what will normally happen is a human ends up pressing override and deploys anyways because it's 5 o'clock. And what better time to push a new model into production than when I'm going home? Yeah, but so it turns out that we actually have to do this. Is anyone doing online learning with streaming data? Oh, you were so nice in the hallway too. Oh no, I'm so sorry. It's really fun, but we don't know how to do validation very good for that. Sorry. So one of the things that I've seen that people do to keep their online models from shifting too much is they more or less set guardrails where they're like, hey, you can change these weights by up to this value per day. And like, if the online learning starts to push it really far out of bounds, it triggers an alert and someone comes in and takes a look at the stream of data that's going on. You can also do something like TFDV on batches of data, computing, the distribution of single records at a time. Not gonna be super great, but you can look at the distributions of your records in a 5-minute window. And if you can wait 5 minutes to push a new model, that's good. And if you can't, I don't know. Cool. Okay, right, so cross-validation, really great. You should definitely use cross-validation. One of the things which really makes me sad is that I see a lot of people use cross-validation for their hyperparameter tuning, and then they give me back those values for the accuracy of their model, and they do it on the same data. It's not gonna work, y'all. Please stop doing that. I'm not gonna call anyone out by name, because I don't have any names. But yeah, just don't. Okay, cool. Great. So cross-validation is great. Sometimes, though, if our data has gone to, what's the word that isn't the word I'm thinking of, has gone to lower quality, our cross-validation won't notice this because it will just say that its performance on these new features is really good. And still, A/B testing with your existing model is important to do. And if you are doing search systems like I used to do before I got out of that, rank skew is a thing, and it's terrible. Oh, right, also, last point, try not to be evil. I'm sure that y'all can figure that out on your own, or more accurately, I haven't figured out how not to do that yet, so cool. Okay, in conclusion, your validation rules don't need to be perfect. I think it's very, very okay for our validation rules to sometimes misfire. If they're misfiring every day, someone's just gonna press override. If they're misfiring once a month, that's okay, I think. You will know your organization better than I do. How many people here use property-based tests? Ooh, we're gonna go through some property-based test slides real fast, because property-based tests are amazing. Okay, cool. Here's a bunch of related links. They're fun, but most of these aren't actually, they're links that you can click on, but if you take a picture of the slide, it ain't gonna help you. I did not think this one through so good. But if you go to the slide deck that I posted online, these links are clickable. I didn't just color them blue, I promise. Okay, so hopefully this is you now. Everything is broken, but that's okay. Okay, cool. There's a bunch of books on Spark. I co-wrote some of them. You should buy this one. I wrote it, co-wrote it, yes. Amazon sells it, and if you have a corporate expense account, it is the gift of whatever season April is, and I recommend several copies. Also, if you have any children that you sort of like, but not that much, I've started a new project called Distributed Computing for Kids. The idea is to introduce children to the world of Apache Spark. Unlike everything else in this talk, it is not a joke. But I can understand the confusion. And I do promise we will replace the gnomes with something that looks less like a drug-fueled library study session before we publish the book for real. Okay, unrelated. Well, not completely unrelated. If you have failing code and you want to turn it into art, you could go visit this website. It does not use Spark in any way, shape, or form, but because I had to give a conference talk, I needed to procrastinate preparing for that, so I made this. And if you want to go see that, it will make a dress for you out of some open source code. It's fun. I don't know if the dresses are any good, but they look kind of cool in the computer mockups. Maybe they are, maybe they aren't. You should come to London with me because the weather here is so nice. Okay, whatever. But property checks. Yes, please do property testing. There's Scala check. There's Spark Testing Base is a testing library, and you can write relatively simple rules like this, and then you don't have to come up with 1 million examples. The computer will do it for you. And even a very simple rule like this will catch a surprising amount of bugs. Just asserting that you're not losing any records during a thing you don't think you're losing any records in will find out that you are wrong. I have found out that I am wrong with this high-quality property test. Yeah, so you should go check out Spark Testing Base. I've got 2 minutes left, and I just lost my voice. So we got time for a question. Does anyone have any questions? No. Okay, I'm going to go back to the slide with the link to the slides on it, because I saw more people taking a picture of the thing where the links aren't going to do you any good. So if anyone, oh man, there were a lot of slides, eh? Holy shit. Okay, no. Okay, cool, yeah. So if anyone wants the slides, you can go to that URL. It'll be pretty cool. And if anyone has questions, I'll be hanging around outside well, until they kick me out of the hallway, I guess. Whatever. Thank you all for coming.